Limit as t goes to 2 of t to the fourth minus 8t squared plus 16 over 3t squared minus 2t minus 8. The first thing we are going to try is plugging 2 in for each of the t's. In the numerator, that'll be 2 to the fourth minus 8 times 2 squared plus 16 divided by, in the denominator, 3 times 2 squared minus 2 times 2 minus 8. In the numerator, 2 to the fourth is a 16. 2 squared is a 4 times a negative 8 is a negative 32 plus 16. In the denominator, 3 times 2 squared is a 12. Minus 2 times 2 is a negative 4 minus an 8. In the numerator, 16 minus 32 is negative 16 plus 16 is a 0. In the denominator, 12 minus 4 is an 8 minus another 8 is a 0. We have 0 over 0 indeterminate form. We need to rework this since these are power functions. We are going to try the factor and cancel method. So we have limit as t goes to 2. The numerator is a trinomial factoring of t squared. Since we have a t to the fourth and a t squared term, t to the fourth is t squared times t squared, and we have a middle term of just t squared, and therefore this will be a trinomial factoring involving t squared. We need two numbers to multiply to be a positive 16 but add to be a negative 8. They need to both be negative then. And it sounds like negative 4 and negative 4 will work. In the denominator, we have a trinomial factoring of t. Since that is a 3t squared, it will be a 3t and a t. 3 is a prime number and is only a 3 times a 1 for its divisors. We need two numbers that multiply to be a negative 8 and add when one of them is multiplied by the 3t to be a negative 2t. 8 is either 8 times 1 or 2 times 4. We can try 8 and 1. 8 and 1 here and here will make 24 and 1. That will certainly not make a negative 2. We can try 8 here and 1 here. That will make an 8 and a 3. That will not make a negative 2. So we must have 2 and 4. If we put 2 here, we will have a 6t, and we put a 4 here, we will have a 4t, and a 6t and a 4t can make a negative 2t as long as the 6 is negative, so we want the minus there, so we have a negative 6t and a plus 4t. So that's fully factored. We still have 0 over 0. The 0 is happening in the numerator due to the t squared minus 4. Actually, both of those are 0 in the numerator and the denominator because of the t minus 2 here. T squared minus 4 does not cancel with t minus 2 because t squared minus 4 can be further factored. It does have a t minus 2 contained within it. We will factor each of them as a difference of squares into t plus 2 and t minus 2. In the denominator, we have 3t plus 4 and t minus 2. We're leaving that alone. A t minus 2 can now cancel. That's removing the 0 over 0 trouble that we were encountering. I will just rewrite this after they have canceled out. There is another t plus 2 in the numerator. We can combine those into t plus 2 squared times t minus 2 over 3t plus 4. We no longer have 0 over 0. It looks like we are still going to have a 0 in one of the locations, but as long as you don't have it in both, it's determinate. It's not indeterminate. That's the 0 over 0 where it's indeterminate. If we plug a 2 in for each of the t's, we have 2 plus 2 squared. We have 2 minus 2 over 3 times 2 plus 4. 2 plus 2 is 4 squared, which is 16. 2 minus 2 is a 0. 3 times 2 is 6 plus 4 is a 10. 16 times 0 is a 0. We have a 0 over 10. A 0 over any non-zero number is always 0.